What's going on, everybody? Welcome back to More Fab Industries. Alright, so today, what you can hear and probably see in the background, listen for the click. We have an 04 Trailblazer that's got some sort of an issue. It's a crank no start. None of the fuses appear to be blown according to the customer. They checked everything that they possibly could. So what we're going to do today is we're going to start by troubleshooting why this thing won't start. Now, these Trailblazers are very common for the fuel pumps going, the fuel pump connector going. We're also very famous for crank position sensors starting to go. Now this has pretty high mileage on it, so we're not going to rule any of that stuff out. But what we want to do first, customer claimed that the check engine light was on, but only after the no start condition happened. It wasn't on before. Now check engine light will most likely illuminate when you start you turn the key, and it doesn't go out until the engine starts. If it stays on, it stays on, but we're going to run some codes and see what we're dealing with code-wise, and maybe we can kind of get an idea of what's going on with this thing. So let's do that. Alright, so I'm going to try to keep this in frame as best as I can. We're going to use the launch scanner on this and see if we can figure out what those codes are all about. Alright, so we're showing no codes there. Let's just do a quick health report on this. See what comes up. Customer was claiming that he had a code for ignition control or injector control circuit for cylinder number 1. Now that could be the presence of lack of power to the injectors or a blown injector fuse or something of that nature. We had him check fuse number 28 on this, which supplies power to the fuel injectors, and the fuse was good. So I don't suspect that's the issue. We do have a body control code. We have a heating code. Let's see what else we get. Alright, so the only two codes that we're showing right now are one in the body control module and one in the heating and air conditioning. The heating and air conditioning one's not going to cause a no start issue, but the body module one might. So we will check that and see what that's all about. Alright, rear washer relay circuit. So that's not going to cause our no start issue. So these codes are pretty irrelevant right now. We don't have any major codes. So now I think what we're going to do is we're going to try to activate the fuel pump. And by activating the fuel pump, we should be able to hear it. And if we can hear it, at least we know the fuel pump is working. If the fuel pump is not working, what we're going to do is we're going to go underneath the vehicle and we're going to start doing some testing with the connector itself to see if the connector is any good. Alright, so let's see. Engine output controls. Fuel pump. Communication error. Fuel pump. Ensure all fuel lines are connected. Press OK. On. Alright, so we have fuel pump relay click, but I do not hear the fuel pump whatsoever. You guys could probably hear that too. Alright, so we have zero fuel pump functionality right now. So what we're going to need to do is we're going to lift this thing up in the air. We're going to check the fuel pump connector. We're also going to check the resistance of the fuel pump motor itself, and that'll tell us whether or not this fuel pump is good. Alright guys, so as you can see, we've got a hold of the fuel pump wiring. Hopefully you can see with that light on it, but this pump's already been replaced once because it's got a brand new connector on it. And it's looks like an Ampro or something like that, so it's been done once. But what we're going to do now is these are the wires actually coming from the wiring harness itself. We're going to probe this gray wire, which is the power wire for the pump. And what we want to make sure of is that when we activate the fuel pump, that we've got the 12 volts there that we should have. And we're just going to use the old fluke meter to see if we've got the voltage. And we're going to use the scan tool to activate the fuel pump. Alright, so the fuel pump is on. Now let's see what we got. And we have 1164, which is the voltage we're looking for. Alright, so now that we know we have voltage to the pump, what we can do is we can actually check the resistance of the pump motor to ground. So we're going to put the meter in resistance mode, and we're going to run between the gray and the black on this harness right here. See if I could do all this one-handed. Maybe not. I'll put the meter up here. Alright, so resistance-wise, we have 2.9 megohms, which means that basically the pump motor in this thing is a wide open circuit. Now, with it being a wide open circuit, the fuel pump is obviously not going to function. So, we can pretty much determine that this thing has a bad fuel pump. We know we have power back at the connector. Now, we don't know if it's load carrying capable, but we do know that we have power back at the connector. We also know that the pump resistance rating is at 2.9 megohms. Now, that shouldn't be the case. It should almost basically look like a short to ground. Maybe 2 or 3 ohms across the motor windings, but right now that's what we're looking at. Is the fuel pump right now is stuck at an open circuit, so the motor is bad. Now, what we're going to try before we do anything so that we can move this thing around today is we're just going to tap on the bottom of the tank, which sometimes will spin the pump motor just enough so that it gains contact again. And we're going to see if we can make this thing work just for a second. So, let's try that. Alright, so here we go. We are literally going to just tap the bottom of this tank while we have the fuel pump activated. See what we get. Nothing. Nothing at all. So this thing needs a fuel pump. We're going to have to put a fuel pump in it, and then it'll be good to go. So, unfortunately, for some reason or another, I don't know what it is, and if you guys have run into this, but every time I found that something needs a fuel pump, it's got a full tank of fuel in it. It always happens when these things have full tanks of fuel in them. So, unfortunately, we have to drop this tank with pretty much a full tank of fuel in it. We might be able to drain some of it out, but I guess we'll find out. Alright guys, so here's a quick example of how things can bite you in the ass when you're working on cars. Now, you saw me do the test of power at the connector coming from the harness, and you saw me do a test of power on the back side of the connector. Now, what you didn't see me do and what I forgot to do was actually test for power on the fuel pump side of the connector. Now, where we're stuck right now, or where we're at right now, what we found is that the fuel pump side of the connector had no power. The harness side of the connector does have power. So now, what we can do is we can actually take power from the fuel pump relay, which is turned on right now, and if we touch the back side of the fuel pump connector and the back side of the harness connector, you'll be able to hear the fuel pump. And there you go. So the problem is not actually the fuel pump being bad. The problem is this connector right here. So all we have to do is order up this connector, replace it, and we will have a much cheaper fix, more inexpensive, and I don't have to drop this full tank of fuel. So always make sure you do your tests and do them again, and then sit and think about it and do it again if you have to, because I could have possibly overlooked this, replaced the fuel pump, put the tank back in, and still had a no start issue because the fuel pump connector was actually bad. So we're going to order up this connector, we'll replace that, and then we'll have a good and ready to go truck. So being that this vehicle already has, and we verified that it's got an aftermarket fuel pump in it, we know that the fuel pump side of the connector has been updated to the new style. So if this thing ever needs a fuel pump again, the connector that is at the fuel pump will be the correct one for this particular application and all the aftermarket applications. So what we did was, this connector is actually not important in any way, shape, or form. The only reason that connector was there was to mate to the jumper harness that goes to the fuel pump. So what we ended up doing was just splicing these 4 wires together. We soldered them. We did not use butt connectors. We soldered them, shrink wrapped them, and then electrical taped them so that they are protected. And we're going to tuck that harness back up in. Now we're going to go into the vehicle. We're going to make sure we have fuel pump, and then we're going to try to start it. Alright guys, so now that we got the fuel pump fixed, we're seeing a pretty significant misfire on cylinder number 6. Very significant actually, which usually means that it's got a bad coil pack. So now we got to troubleshoot that aspect of things. We're going to move this coil pack around and see if it actually changes the misfire, or we may just order a new coil pack, because I know for a fact that these things have issues with the number 6 coil pack. So let's see what happens. Alright guys, so we got it fixed. You saw that we spliced that harness together because it already had the new style harness on it, so we didn't need that extra connector in there. Spliced that together, we got ourselves a fuel pump running, we got adequate fuel pressure, and we also found a misfire in cylinder 6. Now I didn't bother going through and troubleshooting that, we'll save that for another video. I know right off the rip that coil number 6 on those Trailblazers always goes, so I just ordered another one, popped it in, and we have perfect running 150,000 mile Trailblazer. Now, what I showed you guys was a mistake that I made in the troubleshooting process for that harness, and I showed you that simply because I want you to know how important it is that when you have any kind of a connector, you need to test on the power coming into the connector as well as the power going out of the connector, because we very easily could have dropped the tank, put a fuel pump in it, done everything we had to do, plugged everything back in, and it wouldn't have worked. Now, where we would have gotten lucky in this one is that the new fuel pump comes with an adapter harness, which would have replaced the section of harness that was bad. But the customer would have incurred probably another $300 or $400 worth of cost had we replaced the pump, and we didn't need to drop the tank to do the pump because the harness was bad. We could merely splice the harness, solder it, heat shrink it, and everything can be good. So make sure you're doing all the tests that you need to. Front side of the connector, back side of the connector, check for corrosion, check for pin damage, check for pin fitment issues, all that stuff, because you can save yourself a ton of time and you can save your customers a ton of money, or yourself a ton of money, depending on how you go. The fuel pump for that thing alone is almost $300, so saved a ton, and now we have a happy customer. So I hope you guys enjoyed that video. I hope maybe we can do a lot more of the electrical troubleshooting stuff, because a lot of people find that very interesting. We're currently working on possibly getting some new diagnostic tools to do that stuff with, so that we can better show you guys what it's like to actually troubleshoot an electrical device that goes bad rather than just replacing it. So stay tuned for the next one. Thank you all for watching. Thank you for subscribing. If you haven't subscribed yet, please hit that subscribe button. We're in the middle of December. We're at almost 9,000 subs. Want to hit that 10,000 mark by the first of the year, so hopefully we can do it. But have a good day, everybody, and I'll see you on the next one.